This is the Lone Crater YouTube. We hope this video helps.
You start by identifying the function and its domain so you know where critical points can exist. Once done, compute the derivative f prime and simplify it. Factor polynomials or use trig identities to reduce complexity. Make sure to note points where f prime equals 0 and where f prime does not exist, because both are candidates. This step gets you the raw list of potential critical locations. Keep your algebra tidy, so solving the next step is straightforward and reliable. Next, set f prime equal to 0 and solve for x. Use factoring, quadratic formula, or a numeric solver when necessary. At the same time, include any domain points where f prime is undefined, but the original function exists. Once you have candidates, construct a sign chart for f prime or compute f double prime to see concavity. This separates rising versus falling behavior. Make sure to handle repeated roots carefully, since multiplicity affects sign changes and therefore the classification. Finally, classify each candidate. If f double prime at the point is positive, you have a local minimum. If negative, a local maximum. If 0, use the first derivative sign test or higher derivatives. For closed intervals, evaluate endpoints and compare values to find absolute extrema. Once classified, verify by plugging nearby x values or plotting to confirm behavior. Troubleshooting tip: if algebra fails, use a high-resolution plot or a numerical root finder to avoid missing subtle roots or undefined points.
Thanks for watching. Consider subscribing if we helped you.